All right, welcome to lesson 52 of Connecting Math Concepts. We're going to build on some of the skills that we had yesterday, and we're also going to practice a little math fluency. So let's go ahead and get started. 12 divided by 4. 12 divided by 4 equals 3. 9 divided by 3. 9 divided by 3 equals 3. 28 divided by 4. 28 divided by 4 equals 7. 9 times 7. 9 times 7 equals 63. 8 times 4. 8 times 4 equals 32. 54 divided by 9. 54 divided by 9 equals 6. That's right. 3 times 6 equals 3 times 6 equals 18. 10 divided by 0 equals 10 divided by 0 equals 0. I think that should have been 0 divided by 10. 0 divided by 10 equals 0, not 10 divided by 0 equals. 21 divided by 7. 21 divided by 7 equals 21 divided by 7 equals 3. 9 times 6 equals 9 times 6 equals 54. 32 divided by 4 equals 32 divided by 4 equals 8. 24 divided by 6 equals 24 divided by 6 equals 4. 24 divided by 8 equals 24 divided by 8 equals 3. 5 divided by 1 equals 5 divided by 1 equals 5. 63 divided by 9 equals 63 divided by 9 equals 7. 6 times 4 equals 6 times 4 equals 24. 3 times 8 equals 3 times 8 equals 24. 24 divided by 4 equals 24 divided by 4 equals 6. 18 divided by 3 equals 18 divided by 3 is 6. 6 times 6 6 times 6 equals 36. 72 divided by 9 equals 72 divided by 9 equals 8. 4 times 7 equals 4 times 7 is 28. 36 divided by 9 equals 36 divided by 9 equals 4. 10 divided by 2 equals 10 divided by 2 is 5. 36 divided by 6 equals 36 divided by 6 equals 6. And 30 divided by 5 equals 30 divided by 5 equals 6. And 81 divided by 9, 81 divided by 9 equals 81 divided by 9 is 9. 35 divided by 5 equals 35 divided by 5 is 7. 54 divided by 6. 54 divided by 6 equals 9. 3 times 7 equals 3 times 7 equals 21. And 12 divided by 4 equals 12 divided by 4 is 3. And that's all of our fluency. Now we're on word problems. We're going to do two different sections of word problems. One is each and every word problems, and the other part is multiplication or addition word problems. So let's go ahead and get started. Here's problem concept. When you have the word each or every, it is going to always be a multiplication sentence. For example, every day has 24 hours. This would be the multiplication sentence. 24 times hours equals days, except that's wrong. It would actually be 24 divided by times days equals hours. I made a small mistake, accept my apologies. It's been tough learning all this new technology and being a YouTube sensation. Here we go. Problem A. Every flower had 11 petals. So all those flowers in the world that we saw had exactly 11 petals. So we got to ask ourselves a couple questions. First question, what is the first small number? First small number is going to be 11, right? First small number is 11. Okay, now, were there 11 times flowers or 11 times petals? What were there more of, petals or flowers? There were 11 times petals, right? There were more petals than there were flowers. So if we were to do a multiplication sentence, it would look just like this. 11 times flowers tells us petals. So if we had one flower, we'd have 11. If we had 2 flowers, we'd have 22. If we had 3 flowers, we would have 33 petals is correct. Here we go. Next one. There were 120 pages in every single book. All of the books in all the libraries only had 120 pages. So what's going to be our each and every number? Our each and every number is going to be, that's right, 120. And then were there more pages or more books? 120 pages per book or 120 books per pages? There were 120 pages. So that's going to be our big number. And we're going to turn that into our multiplication sentence right here. 120 times books will give us pages. So one book, 120 pages. Two books, 12 times 2, that's 240, and so on and so on. All right, let's try another one. There were 40 boxes. Each box had 8 pencils. How many pencils were there? Oof, this is tough. Luckily, by using our skills, we'll be able to figure it out. So, what is the first small number? Could it be 40 boxes? Or each box had 8 pencils? Could it be 8? And it's going to be 8. 8 is our each number because it goes each box had 8. Now, were there more pencils or more boxes? Were there more pencils or more boxes? Well, there were more boxes because there were only 8 pencils in each box, so there are 8 pencils. So we know pencils is going to be our big number. So when we write out our multiplication, it is going to look just like this. Now I'll wait, or you can pause the video. You know how many boxes there were. You know there were 40 boxes. So it's possible to solve that by multiplying 40 times 8. So if you want to, take another 10 seconds to figure out what the pencils is going to be. So you're multiplying 40 times 8. 40 times 8, write your 0. Put your 2, put your 3. 40 times 8 is... There we go, we got 40, so we're going to put 40 up here. And 40 times 8 is going to give us 320. There are 320 pencils. So if you did that math out on the paper, you can see that each number, 8 pencils in each box, will tell us how many pencils there are total. Here's another one. There were 5 adults for every child. There were 400 adults. How many children were there? A lot of adults, a lot of children, but we could figure out how many there were by just paying attention. What is the first small number? The first small number is going to be 5, right? 5 adults for every child. You have 5 adults for one child. What's going to be your big number there? Is it going to be 4 adults or is it going to be children? They're more adults. So we are going to write that as a multiplication sentence that looks like this. 5 adults for every child, and we know there were 400. So when you have 2 big numbers in a multiplication and you're missing a small number, then you're going to do some division. You're going to do division. You're going to write 400, and then you're going to divide it by 5, and we're going to find out what the answer is, and the answer is 80. 80. So that's how you do each and every. Each or every number is always going to be your small number, and then you're going to figure out what your big number is, write out your multiplication sentence, and then use multiplication or division to solve for that. And there'll be a couple questions on the Google quiz to test for that. Here we go. We got about 5 more problems to go. So sit up, sit straight. Let's go. We got this. Multiplication versus addition. So we're trying to remember, when do we use multiplication? When do we use addition to solve these questions? The times number is what we're always watching out for. So let's go ahead and get started. The air was 6 degrees warmer than the water. It's a hot summer day. Air is 6 degrees warmer than the water. So let's go ahead. Is there a times number? Is there a times number? No, there's no times number. So does that mean it's multiplication or addition? That means it is addition. That's an addition problem. So if you were going to write it out, it would look a little something like this. 6 degrees plus water tells us air. All right, let's find out the next one. Here we go. Debbie was 4 times as old as Scott. Is there a times number? Yes, there is a times number. Yes, there's a times number. Does that mean it's multiplication or addition? That means it is going to be multiplication. That's right. It's going to be a multiplication sentence. If we did it, we'd have our times number. In this case, it would be 4. And then we would multiply it by S. 4 times S will tell us D. 4 times S will tell us how old Debbie is. Here we go. Next one. Problem C. Tim was 15 inches shorter than Beverly. When you're watching this, you can think, oh, I must have been recording that on Monday when the thunderstorm was. Tim was 15 inches shorter than Beverly. Is there a times number in that? Uh-oh. I said, is there a times number? No. Is there a multiplication or addition number? So I apologize. That was my fault. Let's do it again. Tim was 15 inches shorter than Beverly. Is there a times number? No, there's no times number. Is it a multiplication sentence or an addition sentence? It's going to be a addition sentence. All right, so 15 is going to be our first small number. Who is shorter, Tim or Beverly? Tim is shorter, so he's going to be our other small number, and that would look like this. 15 inches shorter than Beverly. All right, problem D. A truck was 12 times as heavy as the cart. A truck was 12 times as heavy as the cart. Does that have a times number? Yes, it does. I forgot to write the word times, but yes, 12 times as heavy as the cart. Yes, it has a times number. Does that mean it's multiplication or addition? That means it's going to be multiplication, right? So you write your multiplication family, you know your times number. Your times number is going to be 12. Times number is going to be 12. 12 times this cart will tell you about the truck. All right? So that's how you work these problems. Your next steps are to head over to Google Classroom and take the quiz. Think of examples of this in your daily life. Are you 2 times as old as anybody? If you're 12 and you know a 6-year-old, are you 2 times? Or can you think of, oh, I'm 5 inches shorter than this person, 5 inches taller? You could drop a comment in the Google Classroom stream if you would like to. And don't forget, always, always, always be safe. Wash your hands. We'll get through this together apart. All right, this is Mr. O'Connell saying bye-bye. Thank you.